Greetings and welcome, friends. Today we are learning a new strategy for solving systems of equations. This is actually our third method. It is in many cases the most effective method for solving equations. It is going to work in situations when the other two show ineffectiveness. The first method was solving by graphing. The second method was by substitution. Substitution worked great whenever our equations had a weak spot, right? Whenever there was an x or y that would have had a positive 1 or a negative 1 coefficient. But substitution would not be fun for this problem because I would have to trudge through fractions, right? If I want to solve this x, I would at some point have to divide both sides by 3. If I want to solve for this y, I'd have to divide both sides by 2. And I don't want to do that because it's going to create fractions. So enters the room the elimination method. This thing is awesome. This problem-solving strategy will bust through all of the extra body armor that this problem has. It has no weak spot, but it will get through it. All right, we're going to look at example 1 as we read these steps. Step 1. The goal of step 1 is get opposite coefficients. Opposite coefficients. I'm actually going to ignore the same coefficients for right now. Most of the time I just aim for opposites myself, but there is another way to do it. So if I'm aiming for opposite coefficients, I want to show you, notice step 1 has a positive 2y and a negative 2y. Those coefficients are opposites of one another, right? Positive 2, negative 2, opposites. Those are done. 3x and 3x, those are the same coefficients. 3 and 3 are identical numbers. Those are not opposites. In some problems, we won't have opposite coefficients, but I'll show you a trick as to how to get those later on. Let's get to step 2. Ours already had opposite coefficients. Add the equations to eliminate one of the variables. All right, check this out now. I'm going to add these equations together. 3x plus 3x, what do I get? How many x's? Let's add these straight down. 3x plus 3x is 6x. All right, and check this out. 2y plus negative 2y is how many y's? It's 0 y's. Those eliminate each other, right? That's beautiful. It's beautiful. Bring down my equal sign. 4 and negative 4, those actually ended up being 0 as well, oddly enough. So the benefit of this elimination method is that I've eliminated a variable, leaving an equation with only one kind of variable, which we know how to solve. All right, so let's see. Do they call that step 3? Yeah, solve the resulting equation. I sometimes include that solving in the previous step. So if I want to solve this for x, what do I do to both sides? Divide by 6. Man, we are low energy today, but that's okay. I'll bring it for all of us. X equals 0. So notice I've actually solved half of the problem. So I used the elimination method to do so. I've got half of my answer. Where's my scroll bar? Here it is. And then last step, substitute the value from step 3 into one of the original equations. Doesn't even matter which. So there's a little bit of, substitution that shows up at the end here. I'm going to plug it into the first equation because those are all positives. And I'll plug it in for that. So step 4. I'm going to have 3 times 0 plus 2y equals 4. That's 0 plus 2y equals 4. That's just 2y equals 4. And I solve by dividing both sides by 2. And I get y equals 2. So my solution is 0, 2. So it does exactly the same thing as our other methods do, only better in certain situations, such as this one, when there were coefficients that were different than 1 or negative 1 for all of these. Okay, let's take a look at monitoring progress question 1. All right, we'll try to get some good practice in today. Monitoring progress question 1. All right, so step 1. Solve one of the equation, or sorry, oh man, I'm so used to saying substitution steps. Multiply one or both equations by a constant in order to get opposite coefficients. My question for you is, do I have opposite coefficients for the x's or the y's yet? Yeah, which variables have opposites? Yeah, the x's have opposite coefficients. I agree, step 1 is done. Step 2, add them up. So let's add these equations together. 3x and negative 3x adds to 0x, which is nothing. All right, those you could think got eliminated. All right, 2y plus 4y is 6y. Equal signs, bring them down. 7 plus 5 is 12. So the benefit of the elimination method is it gets rid of one variable, giving us a single equation in a single variable. How do I solve for y? Divide by 6. And I get y equals 2. Half of my answer. If I want to find x now, I can plug this in for either of the original equations. I'll plug it in there, I guess. So 3x plus 2 times 2 is equal to 7. 3x plus 4 equals 7. Subtract 3 from both sides. Hopefully you guys are getting lots of good practice on solving multi-step equations. 3x equals 3. Ooh! Div 3, div 3. And I get x equals 1. So my solution is 1, 2. Done. They ask to check our solution. We're going to ignore that right now. We'll ignore that right now. Okay. So, that's the idea. Let's actually have you guys do a problem. I think the next thing in your packets is Prac 5.3b. Which looks like this. Actually, I'll take a snapshot of that as well. And let's have you guys try one of these problems. Let's try, yeah, we'll try 1 and 2. All right, you guys get these? Did you find these in your packet yet? There you go. Let's have you guys try some of these before I move on to example 2. I'll be walking around. All right. Yeah, that's a great idea. Internet friends, I'm just going to scroll up to the first example so you can use it as a reference. Probably. I agree. Yep. Yep. So step 1 was done. The y's were opposite. I don't think you'll need to distribute in this case. 2x plus 5x was 7x. The y and negative y canceled out. Thank you. And then we got x equals 3. I'm going to plug it into the first one, I think. I like the first one. It'll be the same either way, you're right. So, yeah, it won't matter whatsoever. So 2 times, instead of x, I'll have 2 times 3 plus y equals 10. 6 plus y equals 10. How do I get y by itself? Minus 6 minus 6. And we get our answer. So y equals 4. All right. Step 1 for problem 2. Do you have opposite coefficients? Yes. Which variables are opposite? The y's. Now wait a minute. This one's negative and this one's positive. Aren't those opposites for the x's? They have opposite signs but different numbers. So that's not what we're looking for opposite. We want the same number and different signs. So step 1 is done. That's nice of them. Step 2, add them up. So, negative 3x plus 4x is 1x, or just x. 2y and negative 2y, you are eliminated. Equals 14 negative 16 is negative 2. X equals negative 2, right? When I combine those. And step 3 is actually done. That's already solved for x this time. That's nice. X equals negative 2. And then step 4, plug what I get into either of the original equations. Don't matter none. I'm going to plug it into the top one because y is positive, but you could pick whichever one you like. Maybe 16 is your favorite number or something. I don't know. Doesn't matter. So negative 3 times negative 2 plus 2y equals 14. That's positive 6 plus 2y equals 14. Subtract 6. Although here dividing wouldn't have been terrible as long as you remembered to divide everybody. 2y equals 8. I think y is going to equal 4 again, guys. Here I say the number 4, so I'm writing 4 when I mean to write 2. So y equals 4. Right? So my solution is negative 2 comma 4, if you want to think about that as an ordered pair. So that's what's cool about this, is the fact that you can add equations together and it still is helpful. Let me actually show that Desmos graph again right now. Let me rewrite this. So let's see. So this was negative 3x plus 2y equals 14. Negative 3x plus 2y equals 14. So there's our first equation. Our other one was 4x minus 2y. 4x minus 2y equals negative 16. All right, so here's our graphs. If I was solving graphically, I'd be interested in where do these lines intersect. Notice I get negative 2 comma 4, which is actually the same solution I got. But, I mean, I've shown you guys to just add these equations together. But is that allowed? Well, let's find out. When I add these together, I had 1x plus 0y's was equal to negative 2. And that gave me this purple line. This purple line's completely different than those other lines. But what feature does it have in common with these other lines? They intersect at the same point. This is like a triple intersection right here. Check that out. And so this is a simpler equation. It's different as far as the lines go, but the one thing in common that it has is all that I need it to have in common. And the benefit of having one of those variables be 0 is that we actually know how to solve that equation super well. Right? So that's the benefit of that. Let's see. Let's try example 2. I think I've only got one kind of like this on your homework tonight. You'll see more tomorrow. Let's try example 2 together. Okay. Step 1. So you guys looking at this, example 2, do any of my variables have opposite coefficients? No. None of them do. Oh man. Guys, how do we do this problem? So yeah, -10 and -5, those aren't opposites. 3 and -6, those aren't opposites. So this is actually what we get to do. Step 1, let's read it. Said multiply, if necessary, one or both equations by a constant. That just means a number. So at least one pair of like terms will have opposite coefficients. So if I wanted to multiply these equations by something that would give me opposite x's, right? If I could get both of those to be 10, that'd be cool, right? A positive 10x and a negative 10x, that would be helpful, right? And I could get the second equation, don't write this part down yet, to be a positive 10x by multiplying by what? What could I multiply -5 to get positive 10? Let me ask this again, friends. By -2. That's right. All right, are you guys catching this? This is the trickiest step. If I wanted, I could multiply this equation by -2, and that would give me a positive 10x, which is opposite of this one. Another option, I wonder if I just want to roll with this so as not to confuse us. We'll roll with this, and then I'll revisit another option. So step 1, let's multiply this second equation by -2. -2 times -5x is positive 10x. -2 times -6y is positive 12y. Equals -2 times 23 is -46. Now notice the benefit there is that now I have my opposite coefficients. Right? You guys getting this? You writing this down? This is like some of the trickiest stuff we've ever done. So let's add these together. -10x plus 10x. What does that become? Nope. Those are opposites, so they cancel out. I just filled in a -10x hole with 10 x's of dirt, and now it's level ground. It's 0. All right? Let's add these y's together. 3y and 12y is what? 15y equals 1 plus -46 is -45. So I can actually create my own opposite coefficients if I need to. And then step 3, if I want to solve for that y, I would divide both sides by 15. And I get y equals -3. All right, so step 1 can be done. All you do is multiply one equation, or both, which we'll see tomorrow, by some number to get me the opposite coefficients that I need. And let's see, lastly, step 4, let's find the other value, the variable x. I'm going to plug it into the first equation because these are all smaller numbers, mostly. Here, try not to be causing noise distractions. So let's see, -10x plus 3 times -3 equals 1. And then you guys, you're experts from here. -10x minus 9 equals 1. Add 9, add 9. Good, we're going to have time for a class question today. This is going to be great. -10x, those 9's canceled out, is equal to 10. Oh, we can do this. Divide both sides by -10. And I get x equals -1. So my solution is -1, -3. Huh. So yeah, it turns out I can multiply an equation by a number and I can still get a solution. Thing of beauty. Now, I didn't necessarily have to aim for opposite x's. I want to just take a look. You guys don't have to write this down. Just follow along up here for a minute. Here's the same problem. I'm just going to get to the opposite. I'm going to get step 1 done. All right, step 1. We just went for, right, we found the number that 10 and 5 went into was 10. I also could have said, hey, instead of 10, actually I'll leave that 10 there. If I want opposite y's, what's a number that 3 and 6 both go into? They both go into 12. Better yet, they both go into 6. 12 could still work, though. But since I'm a mathematician who's an efficiently lazy person, I usually like to work with smaller numbers. If I wanted to get 6's for these coefficients, this one's got -6. If I want to get this to be a +6, what would I have to multiply that be to get +6? What would I have to multiply this by to get 6? Times 2. And if I multiply both sides of this equation, this entire equation, by 2, I actually could get opposite coefficients. So -2, or 2 times -10x, sorry, is -20x. 2 times 3y is +6y. 2 times 1 is 2. Yeah, and it doesn't matter which one you go for. Here, I went for opposite x's. Here, I went for opposite y's. So you can actually pick whichever one's going to be most helpful. And so notice, let's actually just go as far as getting the x solution. -5x and -20x is -25x. These y's, what happens to them? Eliminated. Which is why this is called the elimination method. And that's equal to 25. And then if I solve, I'm going to end up with exactly the same answer. I just get to it a slightly different route. So that's what's actually a little tricky about these problems, is that we actually all could be doing these very differently and choosing different paths. But notice, these x values are the same, and then I could plug that in and get the same result as well for y. All right, let's do one more like this. Let's do monitoring progress question 2. Yeah, 2 will do. Where's my scroll bar? Here it is. Yep. So, all right, here we go. You guys find this problem in your packets? Just keep flipping until you find it. All right, if I want opposite x's, what's a number that 1 and 3 both go into? 3, okay. If I want opposite y's, what's a number that 3 and 1 both go into? 3. So it's kind of like just as good either way, right? I'm going to choose to multiply the second equation by something, though. And the reason I'm doing this is just I was looking at this 12 and 24. I'd rather multiply 12 by something than 24 by something. That's really my only reason. So question, I'm going to aim for opposite y's. What could I multiply 1y to get a +3y? I got to multiply by 3. So my step 1 is I'm multiplying the entire equation, equation 2, by 3. So 3 times 3x is 9x. 3 times 1y is +3y. Equals 3 times 12 is 36. All right, and now I've got those opposite coefficients. Tell you what, sometimes when I want to add this equation and this equation, since they're kind of like there's a space in between them, so I don't get scared or confused, sometimes I rewrite so they're side by side. You don't have to do that, but if you're worried you're going to accidentally add like this one and this one instead of this one, yeah, just you can write them side by side. All right, let's add them up. 9x plus x is how many x's? 10 x's. 3y and -3y add to be 0 y's, which is 0. Those just done got eliminated. And 36 plus 24, I believe. Oh, I was going to write 50. It's 60, isn't it? Yeah. It's... So let's see. And then solve, divide both sides by 10. So I'm going to get x equals 6. All right, so the elimination method works awesome. Actually, this problem wouldn't have been a bad one to use substitution on anyway, right? Because that's a positive 1y. So let's solve for y. I'll plug this in here. So here, Devin, let's plug this in. 3 times 6 plus y equals 12. 18 plus y equals 12. No? No? Yeah, this is a positive 18, so I'll subtract 18 from both sides. So my solution is 6, negative 6. All right, thank you for watching, internet friends. Have a great day. Bye-bye.